Welcome back, friends. So in today's video we will be working on project number 14, that is Titanic survival prediction using logistic regression. For this project we will be using the dataset which is provided by the Kaggle, the Titanic dataset. In this dataset we have 12 columns with 891 rows. I will be providing the link of this dataset in the description below. Now moving further, so first we will import all the libraries. First one will be NumPy, then Pandas, then Matplot, from sklearn dot model selection, import train test split, accuracy score, and this. Yes. So what is NumPy? NumPy is used for creating arrays. Then we have Pandas. Pandas are used to convert our dataset into Pandas data structure. Then Matplot and Seaborn are used for plotting graphs. Then we have train test split, that is used to split our data into train and test data. Then we have logistic regression, which will be used to train our model. And then we have accuracy score, that will be used to analyze the accuracy of our model. Now first, so I have already uploaded the dataset titanicdata.csv. You can just download it from here and then upload it using this upload button, and you can just upload. Now first we will do a data collection. So data collection, let's name as Titanic data. Titanic data is equals to pd.read csv, and we have Titanic data. Titanic data.csv. Let's print first 5 rows. So we can see we have the first 5 rows here, and we have to predict the survived column, this one, whether the person survived or not, using all other parameters, or you can say columns. Now we will be printing number of rows and columns. So Titanic so we have total of 891 rows and 12 columns. Now we will check for the missing values. Checking for missing values, Titanic data dot is null dot sum. So as we can see, we have some missing values in age column and some missing values in cabin and 2 missing values in embarked. So what we will do first, we will handle the missing values. Handling the missing values. Okay, first we will handle the age column. For that we will replace all the missing values with the mean of the age column. Okay, so what is mean? Mean is the average of all the values. So we'll find the average or mean, and then we will put that mean into the missing values. So age mean is equals to Titanic data of age. So our mean has been calculated. Let's print it. Print age of mean. So our mean is coming out to be 29.69. Now we will replace the missing value with age mean. So Titanic data of column age is equals to, or you can say dot fill. Now we have to replace age mean, and in place is equals to true. Okay, so our values, our age column has been updated. Just to check what we can do, we can just print this again. So we don't have any missing values in age column. Now moving further, we will find the mode of the embarked and replace it with the mode. So to find the mode, what we can do, we can just print Titanic data, yeah, that's correct, mode of 0. So it will tell us the mode is S. So we will replace S with the missing values in embarked. Okay, so replacing, saying the missing values in embarked column with mode. So Titanic data dot fill, and yeah, same as the previous one. No. So what we can do next, we can just print in place of print. So we have cabin as well. We have to the cabin. Okay, so cabin has some text data, and 687 values are missing. So what we can do is we can just drop the cabin column, as it will not add a significance to our model. So just drop it, or say removing, or say dropping the cabin column from the dataset. Okay, so Titanic data is equals to Titanic data dot drop. We have columns cabin, the axis is equals to 1. So we have dropped the Titanic data, sorry, the cabin column. Now we can print the missing values again just to check. So it will be Titanic data is null dot sum. So we don't have any missing values now. Now we can move further. Now let's analyze the statistical measures. So Titanic data dot describe, so function. Okay, so we can see that the total count is now 891 for all the columns, and minimum value is 1, and for the maximum value we have 891 is the maximum. And we can also see that 25% of the value is less than 223, and 50% of the value is less than 446, and 75% of the value is less than 668. And we can also see that passenger ID, do not add a significant to our model, as it is just a ID. Same goes with the name, as it also do not add a significance to our model, and for ticket as well. So what we can do, we can just remove passenger ID, name, and ticket. I will be doing it later on. So first I need to know the distribution of the class of survived. Okay, so what we can do, we can see how many of the persons survived and how many of them do not survived. Just just to note that. Okay, so let's Titanic data. We have to find for the survived column dot value counts. So it will tell the distribution of the survived column. So from 891 records, we have 549 records which do not survived, and 342 are the ones who survived. Now what we can do, we will go for data visualization. It will help to know that how our model will work. So first we will set our SNS. So first we will be doing for the survived column. Okay, so first we have to make a count plot. So plt dot figure, there's fixed size, let's around 10,5 is okay. So we can see more than 500 people, around 550. How many of the 550 people did not survive, and around 350, it was 342 people survived. Now let's see, let's visually see that the sex of the people who survived and who do not survive. So plt dot figure, and fixed size is equals to, let's 10,5 is okay. SNS dot count plot, x is equals to 6, and data is equals to, we are using Titanic dataset. Titanic data. So we can see there are more than 550 people who are male and around 300 person who are female. Now we will see the survival rate. So for that, what we can do, SNS dot count plot, x is equals to 6 and u is equal to survived. So in this we can see from around 650 males, only 100 of the around 100 males survived, and around 450, or you can say around 480 males survive or do not survive. And same goes with the female of around 220 females survived, and around 80 females do not survive. Now we can do it for the P class as well. So SNS dot count plot, we have x is equals to P class, use survived. So there are, I think, 3 P class, I think so, 1, 2 and 3. Yeah, so we have 3 P classes, 1, 2 and 3. We can also analyze it. We have around 140 person who were in P class 1 who survived, and around 70 who did not survive. You can analyze for other data members as well. So moving further, I need to know what are the I need to know what how many values are there in the embarked, how many different values are there, or you can say unique values are there in the embarked column. So for that, what we can do, Titanic data embarked dot value count. So it will give all the different values. So we have three values, S, C, and Q. Now what we can do, as our model do not understand the textual data, we will encode it into numerical form. So what we will do, we will convert these into numerical form. Okay, so converting categorical column to numerical. Okay, so Titanic data dot replace, we have to replace sex first. So sex, we will go male as 1 and female as 0. Now we will do same for the embarked. For S we have 0, for C we have 1, and for Q let's assign it 2, and in place PLA in place is equals to true. Okay, we have capital here. So we replaced our column. So let's see is our data has updated or not. Titanic data dot head, it will print the first 5 rows. So our embarked has updated, our sex has updated, and we do not require ticket, we don't require name, we do not require passenger. Other than these 3 columns, every column has a numerical value. That is good. Now we will splitting target and feature column. Okay, so X is equals to Titanic data Titanic data dot drop, we have dot drop columns is equals to, we have force field passenger ID, then we have name, then we have ticket, TICKET ticket, then we have survived, and access is equals to 1, and then we have Y, it will have the target column. So we have splitted the data. We do not require passenger ID, name, and ticket, and survived because survived is a target column. It survived is stored in Y. So let's print X and Y. Print X and print Y. Yeah, so our data looks good now. Now split our data into training and test data. Splitting the data into test and training data, xtrain, xtest, y test, y train, and y test is equals to train test split. We have the original data columns here. We don't require this. Just run it. Now just print x.shape. So originally our data set has 891 rows, but after splitting into 80 and 20%, we have 712 records in train xtrain variable and 179 columns in xtest variable. Now we will do model training. Model is equals to logistic regression. So our model has been initialized. Now we will train it. Model.fit. What are the xtrain? We will use training set, train, and output is y-train. So it will map all the values. So our model has been trained. Now we will predict the output and find the accuracy score. Xtrain prediction. So model.predict. So our model is 81.17% accurate. So what I did, so first our model predict the values of the training set that we used to train our model. Okay, so all the predictions are stored in xtrain prediction. It will contain 0 1 1 0 like this, and then we will match all the values of the xtrain prediction with the our original y-train. Then it will accuracy score will tell how accurate our model is by checking the values. So it will print the accuracy score. So our model is 81.17% accurate. Now we will do same for the test case, that is the actual test of our model. So accuracy score on test data, x test prediction. Now we did same. So our model is 78.21% accurate. So any model with above 70% accuracy is considered as a good model. So now what we'll do, we will make making predictive system. So for that, what will we need? We need input data. I will fill it up after some time. Let's complete the further code first. Input data as numpy array. If my prediction of 0 is equal to 0, yeah. So first what I did, so input data, so I casted our input data into numpy array, then I reshaped it. Why I reshaped? Because we are predicting it for only one record, that is why I reshaped. Then our model predicted the output for the input data, then I printed the prediction, and if my prediction is 0, it will print the person did not survive, else the person survived. So let me fill the input data. So for input data, what I can do, just go to my download section and just open it with notepad, edited notepad. So we have this. So or we can do, as this data is not correct, or you can say it is not casted to a correct form, so we can take, So we can take data that we converted. Okay, so where is our data? So this is our data. We need survived p class. We need p class, that is 3. So 3 comma, we need sex, age, just copy it, sex, ticket, fare, embarked, just copy it and paste it, add commas. So what should be the output? Output should be 0, that the person did not survive. Let's see. So we have 8 features and it is expecting 7, so we gave one feature extra. Let's see what we did. We have survived, we have p class, we have sex, so we have 3 1 22. Let's see, we do not require tickets, so 2177 should not be there. Yeah, it should not be there. Just a minute. So 217 should not be there. So a person did not survive, that is correct. So our model is working fine. So that's all for now. So if you have any query regarding this project, do let me know in the comment section, and don't forget to like and subscribe. Thank you.